Hi everyone, I am Pranshak and welcome back to my YouTube channel. Today we will be solving today's Leetcode daily challenge, which is walking robot simulation. So let's see what is this question and how we can solve it. So in this question, we have been given with a robot on an infinite xy plane starts at point x 0, 0 facing north. Okay, the robot can receive a sequence of these three possible types of commands, which are minus. If we have been given -2, then robot needs to turn left 90 degrees. If we have been given with -1, then robot needs to turn right 90 degrees. And if a positive integer between 1 and 9 is given, then the robot will move forward k units, 1 unit at a time. Okay, some of the grid squares are obstacles. Okay, the ith square is at grid point obstacle I. Okay, if the robot runs into an obstacle, then it will instead stay in its current location and move on to the next command. Okay, we have been given that if there is any obstacle, then robot will not move forward. He will stop before it and then will move when we have been given with next command. Okay, and we need to return the maximum Euclidean distance that the robot ever gets from the original squared. Means if the distance is 5, then we need to return 25. It means 5 ka square. Okay, so let's see what is this saying. So it is saying that we have been given with an xy plane on which robot is at point 0, 0. Okay, and in the first example, our commands are 4, -1 and 3. 4, -1 and 3, and our obstacles array is empty. Okay, so in first example, we don't need to care for obstacles. Let's understand first what are these commands, and then from the second test case, we will understand the use of this obstacles array. Okay, so first we have been given with this, and now the first command is 4. So it means what we need to do, we just need to move forward 4 direction, 4 units, and this is east, west, north, east, west, north, south, right? So first, initially the robot is facing north direction. Okay, and we need to move 4 units forward. So what it will become, 1, 2, 3, 4. He will reach 0, 4, right? And then we have been given with next command as -1. So what was -1? -1 means turn right 90 degrees, right? -1 means right, we need to turn right, and -2 means we need to turn left. Okay, so here robot will turn right. Okay, and now we need to move forward 3 units. So it will reach 3, 4, right? It will reach 3, 4. Now we have been come to the end of this command array, and we need to return the Euclidean distance, which will be 3 square plus 4 square under root, which will be 5, right? And we have been given with that if distance is 5, then we need to return its square, which is 25. Or we can say that we don't need to take the square root of this, and we can simply return 25 here, right? Now let's understand what's the use of this obstacle array. Okay, now in the second example also, we have been given with the robot at coordinate 0, 0. And let's see what are our commands and the obstacles array. 4, -1, 4, -2, 4. 4, -1, 4, -2, 4. And what are obstacles array is 2, 4. Okay, and obstacles array is 2, 4. Cool. Now initially robot is facing in the north direction, so it will move 4 points, 4 units forward, and with each the coordinate 0, 4. And -1 means turn right. Okay, -1 means turn right, so it will turn in this right direction. Okay, and then move 4 units forward. But see, if while moving the 4 units, if it will move 4 units forward, then it will reach 4, 4. but there is an obstacle at point 2 comma 4. At this point there is an obstacle at this point, right? Let's mark it with at this point, right? So robot cannot cross this obstacle. It means robot will not reach to this point and will stop at this point only, which is 1 comma 4. Robot will stop one point before the obstacle, this is 1 comma 4, and will not move the 4 units in the given direction. And now minus 2, again robot will turn left, right? Minus 2 means left. So again it is facing the north direction, right? And now again it will move 4 units forward. Okay, so 1 2 3 4. Now it will reach here, and now the coordinate is 1 comma 4 plus 4 8, right? So now we can take the Euclidean distance as 1 square plus 8 square, which is 65 units away, right? Or we can just say that we need to take the maximum of all of these. Like initially the robot is at 0 comma 4 to 0 square plus 4 square, which is 16, and then in the middle the robot is at 1 comma 4, so 1 square plus 4 square is equals to 17, right? So we can take the maximum of all of these distances, and the final answer will be max of all of these, right? So it is a, see, so whenever we are given with this positive integer, so no worries, then we just need to move forward in that direction. But whenever we are given with this integer, when we need to change the direction, this is a little bit tricky. So let's see how we can tackle this thing, because moving forward is a quite straightforward thing, but how we can tackle the thing of changing the direction. Okay, so it is east, west, north, south, right? So whenever we have moving in the east direction, so the coordinates will be 1 comma 0, right? Whenever we are moving in the north direction, the coordinates will be 0 comma 1, right? Whenever we are moving in the west direction, it means negative of x, right? It is y, it is negative of y, it is x, right? So it means minus 1 comma 0. And whenever we are moving in the south direction, it means 0 comma minus 1, right? So we can create a direction vector in which we initially the robot is pointing to the north direction. So we can start with north, and then in the right direction, which is east, 1 comma 0, and then in its right direction, which is 0 comma minus 1, and then in the right direction of south, which is minus 1 comma 0. So we can declare a direction vector in this way, in which if we are moving, these are the coordinates whenever we are moving in the right direction, and these are the coordinates whenever we are moving in their left direction. So with the help of this coordinate array, we can tackle the case of changing the direction. Okay, so let's see how we can code this, then you will get a much good idea. Okay, so first of all, also we need to store the obstacles so that we can compare whether the current coordinate contains is an obstacle or not. Okay, so let's create a set in which we can store the obstacles. Pair of int comma n, and we can name it as st, and then we can iterate the complete obstacles array and simply store it. So as it is given as vector of vector and we have created as pair of pair, so we have to insert each index one by one. Obstacles of I of 1 code. Now what we need to do is we need to create a direction vector, right? Starting with the north direction, which is 0 comma 1, and then east, which is 1 comma 0, and then south, which is 0 comma minus 1, and then west, which is 0 comma minus 1 comma 0, right? And the starting coordinates are x is equals to 0 and y is equals to 0, right? So let's start with the command cell. Commands dot size and I plus plus. And now if commands of I is equals to minus 1, then what we need to do is we need to move in the right direction. Okay, and the initial direction was north, so we can start it as d is equals to 0 north, because as it is pointing to the north direction. Now if the command is minus 1, it means we need to turn in the right direction, and in the right of north, which is east, so we can increment the d by 1, right? D is equals to d plus 1. But what if we go out of bound? So for that we can just simply modulo it by the size of direction vector, which is 4. Now if commands of I is equals to minus 2, which means we need to turn in the left direction. But see, there is a case. If we are already at the north direction, and see, like if we are moving in the right direction, then we just simply incremented it by 1. But we are moving in the left direction, then we can simply decrement it by 1. But no, because if we are at the north direction initially, then if we try to decrement it by 1, then we will go negative, we will reach the negative index, which will give us error. So for moving in the right direction, for moving in the left direction, what we will do is we will increment it by 3, because after north, which index comes? West, right? So that's why, and this is for west. Let me write it in comments here. First is north, then east, then south, and then west. So after north, if we will take a left turn, then we will reach west. So that's why we have done d plus 3, and we saw that we not go out of bound, so we have modulo it by 4. Now else, if we just reach to if we receive a command of positive integer, now what we will do is we will simply move that number of units. But there is a case of obstacle, so we can't just simply move that number of units. We need to move one by one, so that we can compare whether this is an obstacle or not. Okay, now let's start moving one by one unit. So j is less than commands of I and j plus plus, right? Now we will initialize dx with direction of d comma 0 dot, we need to write as first, as we have created a vector, and then dy is equals to direction of d dot second. So in this way we have got the direction in which we need to move. Now if our set contains these x plus dx comma y plus dy, it means this is an obstacle and we can't move forward, so we just need to break. Otherwise what we can do is we can just increment our x and y by dx and dy, right? And also we need to initialize our result as 0, and we can take the maximum of result comma x square plus y square, right? And by the end of this loop we can simply return our result. So now let's try run this. What we have done here is, sorry, I have declared it as int, which is vector of pair of int comma int. Yeah. So it's working fine. Let's try submitting it. Yeah, it's working fine. Now let's discuss this time and space complexity. So as you can see, we are using this one loop for iterating the obstacles array and this another loop for iterating the commands array. And we might ignore the time complexity of this loop as our k can be long as much long as 9. So it is just can go to 9. So we can ignore it as well. So what will its time complexity become? Its time complexity will become big O of m plus n. M to be the size of obstacles array and n to be the size of commands array, right? And what will be its space complexity become? We have used a set space of set for storing all these obstacles, so its space complexity will become big O of m, right? So yeah, that's all for this question. I hope you got it. If you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys. See you in the next video.